Today's lesson is all about polygons. So this is a lesson 11.3. First of all, a polygon is a figure with at least 3 sides. So basically a triangle and up. Everything that has more than 3 sides, 3 or more I guess, is a polygon. A vertex is a point where 2 sides intersect or where they meet. So basically the points on the edges. And a polygon is classified by how many sides it has. Now you've heard of some of these polygons before. 3-sided figure is a triangle. 4-sided figure is called a quadrilateral. A pentagon has 5 sides. Hexagon has 6 sides. A heptagon has 7. An octagon has 8. I don't know if I have it on here, but a nonagon has 9 sides, and a decagon is 10 sides. Now, figures can have hundreds of sides, and almost every type of figure has some kind of name. If you look it up online, almost all side figures, all kinds of figures that have all kinds of sides have an actual name. But we're not going to talk anything about really a nonagon or a decagon today. So you have to know how many sides some of these things have. Like I said, we're not going to go really past 10. You probably are familiar with a lot of them, but you maybe aren't familiar with a heptagon or a nonagon. They're just a little different. We don't talk about those or use those a whole lot. So polygons have more than 3 sides, 3 or more. Now there's 2 kinds of polygons. There's called regular polygons, and just like what I have up here, and then just a polygon. So regular polygons have all sides and all angles that are congruent, and the congruent means equal or the same. So a regular polygon has all sides and all angles, and it's congruent. So if I look at my things up here, I have 4 different polygons. We're going to talk about if they're regular or not. So if I look at number 1, is number 1 a regular polygon? No, it's just a polygon. It's not regular because all my sides are not equal and all my angles are not equal. This is 90 degrees. This is who knows what this is, and this is who knows what 45 and 45. So I know that's not regular. If I look at this one up here, number 2, I know this is a regular because it has the same sides and all the same angles. So that is a regular type of polygon. Number 3 is also a regular type of polygon. I know that all these sides are the same length. So this would also be regular. Number 4 is not regular, but it's still called, let's see how many sides are there, 1, 2, 3, 4. There's still 4 sides. So it's not a regular polygon, but it's still just a quadrilateral. It's a polygon. It's a quadrilateral. Same thing with this one. How many sides does this have? 1, 2, 3, 4, 5, 6, 7. This is a heptagon. A regular heptagon. If I go back to number 2, it's a square, or actually it's a quadrilateral because I have 4 sides. We're not going to get too detailed. We're just going to call it the regular quadrilateral. Number 1 would be a polygon. It's just a triangle. It's not a regular triangle, but just a triangle. So you can go back and you can rename them if it asks you if it's regular or not, and then it might ask you what type of polygon it is. So according to the sides, what would you call it? Another vocabulary word I have for you is a diagonal. Diagonals connect 2 vertices that do not share a side. So basically it goes from one point to another vertice that's not on the same side. So like up here I have a diagonal AD. And I have a diagonal BC. So here's AD, here's BC. It just goes to the opposite corner. Now we aren't going to use diagonals a lot in 8th grade math, but you get to use diagonals a lot when you get to high school geometry. So you just kind of need to know what it is, and they can be used for a lot of things. So just make sure that you have an idea of what a diagonal is. Like I said, we're not going to use it a ton this year, but you will in geometry when you're in high school. All right, 2 other vocabulary words I have for you. The first one is convex. And this is when you put diagonals inside a polygon, and it's all on the inside of a polygon. So it's basically if you would draw a polygon. Okay, so there's my polygon. And if I would take and I'd make my diagonals all in here. Let's see, this one. There's all my diagonals. Let's see, I probably have this one yet. Tons of diagonals, and they're all inside of the original polygon. Inside of the original polygon. Now, a concave polygon is when you connect the vertices and one line or one diagonal is on the outside of a figure. So you can kind of see here, if you look at this one a little bit, you can see that if I'm connecting all my points here, why can't I click on this? Anyway, if I would connect, so I connected here and I connected here, those two. I took over here and I connected down here. And you always take the path of least resistance, so it's right directly to it. And notice how they're on the outside, like these are on that side. This one is on the outside. So if they go through the outside of the polygon, then it's called a concave polygon. So like for example, if I would draw a star, and I'd say, okay, connect the vertices, and I connect them like this, and this, and this, and this. This would be a concave polygon because these two right here are on the outside of the figure. So concave and convex, two vocabulary words you need to know. All right, so another question that comes up with polygons is how do we know the sum of the angles in a polygon? Let's think about, let's go back to triangles. We know that in a triangle, there are 180 degrees in that triangle. We talked about that the other day. But let's say I have a polygon. How do I know how many, the sum of all the angles in each polygon? And there's a way to do it. So let's look at some polygons. Here's a polygon. This would be a five-sided figure. This is called a pentagon. And there's a way to determine, by using the same formula, there's a way to determine how many degrees are in every single polygon. So let's look at this pentagon. If you notice on this pentagon, I split it into three different triangles using my diagonals. So I connected sides together, vertices together, and I created triangles. So I know that in this pentagon, this is 180 degrees. This is a total of 180 degrees. This is a total of 180 degrees. So we're going to go back to what we know with our triangles. And then we're going to take 180 times it by 3. 180 times it by 3 because there's 3 triangles. And I get 540 degrees. So all these together, this plus this plus this plus this plus this is together 540 degrees. Okay, so here's another let's see, polygon. So I think there's 8 sides here. So notice I split this whole thing into so many triangles. So how many triangles was this split into? If you can tell, it was split into 6. I even have a number for you. So this is 180. 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 So if I multiply 180 times 6, it gives me 1080. If I would add all these together, all these degrees, it's going to equal 1080. So there's actually a formula that you can use for any type of polygon. And if you think about it, I bet you can get it. So this was a 5-sided figure, and I multiplied 180 by 3. And this was an 8-sided figure, and I multiplied 6 by 180. So you probably can see some relationships. So like my pentagon has 5 sides, but I multiplied 3 by 180, and my octagon, I had 8 sides, and I multiplied 6 by 180. So you can probably start to think of, you're always going to multiply by 180, but how do you get the number of how many triangles there are? And it's very, very simple. All you do is you take the number of sides that you have, and you minus 2, because that number of sides, because if you look at these, the number of sides, we're going to minus 2. So if I have 5 sides minus 2, that gives me 3 triangles. And I can minus 2 because some of them share 2 sides. Look at this. Not all of them do, but some of them do, so that's why we minus 2. So it's your number of sides, and here's the equation. Your number of sides minus 2 times weight is going to give you the total sum of degrees. So the total sum of degrees. So let's try one together. So if I have a 15-sided figure, well, actually, let's look at the top. It says find the sum of the angles of a 10-sided figure. So I would take the number of sides minus 2. So that would be 8 times 180. So 8 times 180 would be 1,440 degrees total in that figure. Now I want you to try to do these two by yourself. I want you to figure out how many total degrees are inside each of those. Okay, the 13 one would be 11. Oh, I'm sorry, 13 minus 2. This will be this. Okay, so this is the total sum of all the angles inside there. Now, another question I have is, so let's go back to the 15-sided one. That's like me adding all of these together to figure out, and adding all these together will give you this number right here. But let's say I want to know what each individual angle is by itself. If I want to know what each individual angle is by itself, I'm going to take this number and I'm going to divide by how many vertices there are. So there's going to be 15 vertices. I'm going to divide this by 15. And so each angle in here is 156 degrees. Each one 156 degrees. So let's do the other one over here. So this is all these added together. There we go. All of them added together. Now, if I want to know what each individual one is by itself, I'm going to take 1,980 divided by 13, and that's going to give me what each one is all by itself. And for that one, it's going to be roughly 152.3 degrees. So being able to find the sum of the whole thing and then find each individual one is an important thing for today. So let's go back. I'm just going to go back to this one. Let's go back to the octagon. So let's say we go back to the octagon. We know the octagon, I think, was 1,040 or 1,080, my bad. Okay, so all together was 1,080. That's all these added together. If I want to know what each one is by itself, I'm going to take that and divide by 8. And I get each one of these is 135 then. But if I take 135 times 8, I'm going to get back to my whole sum. So being able to do those two things is a really important thing for today. All right, the last thing I'm going to show you is a tessellation. A tessellation is when something can easily be put into a picture like I have up here, where the vertices meet together and it equals 360 degrees. So if I look at these tessellate, because if I look at like where they meet, it makes a perfect 360 degree circle. So this plus this plus this plus this is going to be 100 or 360 degrees. So that's how you know if something tessellates. If it all together, if you add the vertices up and it equals 360. So the question is, how can you tell if something tessellates? The first thing you have to do is you have to find the total degrees, total sum, just what we did. Okay, and then you're going to take that total sum and you're going to find each individual angle. Okay, and then the last thing is you're going to divide by 360 to see if it tessellates. And if it does, If it does divide it, it tessellates. And if it doesn't, mean it doesn't come out equal, it does not tessellate. Okay, so let's do this one together. So does a pentagon tessellate? So five-sided figure, the first thing we're going to do is we're going to find the sum in there. So it's 5 minus 2 times 180. We did this already. 5 minus 2 times 180. So it'd be 3 times 180. Be 540. Then we're going to find out which each individual one is. So we're going to divide by 5. And I get 108. Okay. And then I'm going to take 360 divided by 108. And it is 3.3. So it does not tessellate because it doesn't come out as an even number. If it would come out as an even number, then it would be a tessellation. It would be able to tessellate. And we'll talk about this a little bit more tomorrow in class. So if you have any questions, let me know, and I will talk to you tomorrow.